Okay.
So there is a solid object floating in the water, and 3/4 of its volume beneath the water. So that's what we know. And the question is, what is the density of this object? Okay. What we can do is calculate the weight. The weight of the object is equal to the weight of the water here, right? Let's say the volume of the object is V times the density times the gravity will be the weight of this object, right? Which is equal to the water is repelling, which is 3/4 of its volume times the density of the water times G. You understand here? So we can cancel here, the same thing, cancel here, the same thing. So the density of this object is 3/4 of the density of water. So if you plug in the water, we know is 1,000. Use your calculator, you'll get 750 kilogram per cubic meter.
So the formula is that weight is equal to whatever that is?
You mean here? That's
Yeah.
the weight.
It's equal to that?
Is equal to
That,
the water
whatever they give.
of the weight of the water, right?
Okay.
Right? Because it's 3/4 is under beneath the water, so the volume of the water is 3/4 of the volume of this object, right? So that's number 10
That's 11.
or 11, and then number 12. Liquid flows through a pipe. So liquid flows through this pipe. The diameter is 3 centimeters, which we know the radius is 1.5. Okay? Be careful when they gave you diameter, because when you calculate the area, you need to use the radius. And the velocity is 2 meters per second. Find the flow rate. What that means, the flow rate is 1 second. In 1 second, what's the volume of fluid passing this plane? Okay? So 1 second, the amount, for example, going out is 2 meters. Right? Actually, it's equal to the area of this pipe, the area of this pipe times the velocity. That's how you calculate. So the area is pi r squared times the velocity. Remember to convert this centimeter to meter. It's 1.5 times 10 to minus 2, negative 2 meter. So pi times 1.5 times square, velocity is 2. So calculate these, you will get 1.4 times 10 to the -3 cubic meter per second. Okay. So 12, 13, how much pressure does it take for a pump to supply the drinking fountain with isotones? So the pump, for example, is here. Here is a pump. And then here the pressure is P1, here the pressure is P2. The drinking fountain is 30 meters above the pump, okay? And the pressure is 300 K. What is the pressure here? In order to have a pressure of 300 K here, so according to the equation, is P1 plus so you need to give higher pressure to move the water to here with a pressure of 300 K, right? You need to give higher pressure because you need to move, give the fluid a potential energy to go to the top. So this P2 plus should be equal to the initial pressure. Which is the equation. So the difference will be this. And then we know P2 is 300 K plus 1000 times 8 times H is 30. If you calculate, you got 594 K. Okay? You understand here?
Yeah.
It's only the